This is a recast of the 8,000-word piece, Explainable AI, XAI, from Schneepat.com. This article discusses the importance of explainable AI, XAI, techniques in enhancing transparency, trustworthiness, and accountability in machine learning algorithms. It explores various methods and challenges in achieving explainability, as well as the trade-offs between accuracy, interpretability, and model complexity. The goal is to ensure that AI systems operate within legal and ethical boundaries, while empowering humans to make informed judgments. Let's listen in.
Today we're talking about explainable AI, or XAI, which is a rapidly growing field within machine learning techniques. As AI systems become more complex and capable of making critical decisions, there is a need for us humans to understand and interpret their outputs. XAI aims to bridge the gap between the opacity of AI algorithms and our need for explanations and justifications for machine-based decision-making.
That's right, Samantha. The lack of interpretability in AI systems poses challenges in various domains like healthcare, finance, and criminal justice, where transparency and accountability are crucial. While traditional machine learning models prioritize accuracy and performance, XAI focuses on providing meaningful explanations about the internal workings of these AI systems.
Absolutely. The article mentions that machine learning techniques refer to a broad range of computational methods that enable computers to learn and make predictions or decisions without being explicitly programmed. These techniques are rooted in the field of artificial intelligence and are increasingly being applied in various domains like healthcare, finance, and transportation.
That's correct, Samantha. The fundamental concept behind machine learning is to develop algorithms that can extract patterns or insights from large datasets and use them to automatically improve performance or make accurate predictions. These algorithms are typically categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning.
Supervised learning involves training a model using labeled data, where the algorithm learns to map inputs to desired outputs. Unsupervised learning focuses on finding hidden patterns or structures in unlabeled data. And reinforcement learning utilizes a trial and error approach in which an agent learns to make decisions or take actions based on rewards or punishments.
Right on, Samantha. By leveraging these machine learning techniques, the goal is to develop robust and interpretable AI models that can provide insightful explanations for their predictions or decisions. This ensures transparency and trustworthiness.
Now, let's move on to the concept of explainable AI, or XAI. It aims to address the inherent black box nature of AI models. Traditional machine learning algorithms often produce accurate predictions, but their decision-making processes are largely uninterpretable by humans. XAI bridges this gap by developing machine learning techniques that not only provide accurate predictions, but also offer explanations for these predictions that can be understood and trusted by humans.
That's right, Samantha. XAI focuses on providing transparency and interpretability to AI models by offering insights into the underlying reasoning and decision-making process. This is crucial in domains where interpretability is of utmost importance, such as healthcare, finance, and criminal justice. By enabling humans to understand the reasoning behind AI predictions, XAI strives to build trust and acceptance in AI technologies, while also mitigating the risks associated with algorithmic bias, discrimination, and unfairness.
Absolutely. The pursuit of creating intelligent machines has led researchers to explore techniques that not only generate accurate predictions, but also provide insights into the decision-making process. XAI is one such approach aiming to enhance the transparency and interpretability of machine learning models.
Exactly, Samantha. By providing meaningful explanations for the predictions made by algorithms, XAI enables users to understand the underlying factors contributing to a particular outcome. This has significant implications in various domains such as healthcare, finance, and law, where it is crucial to justify and explain the decisions made by AI systems.
Right you are, Paul. XAI techniques can be categorized into two broad categories: model-agnostic and model-specific explanations. Model-agnostic methods focus on generating explanations that are applicable to any type of model, while model-specific techniques leverage the specific characteristics of a given algorithm to provide more tailored explanations.
That's correct, Samantha. The development and adoption of XAI techniques hold immense potential in promoting trust, understanding, and acceptance of AI systems in society. It allows us to have confidence in the decisions made by AI algorithms and helps us identify any biases or errors that may be present.
Exactly, Paul. One of the key reasons why XAI is of utmost importance in the field of machine learning is its potential to enhance the understanding, trust, and adoption of AI systems by humans. As AI becomes more prevalent in various aspects of our lives, it is crucial to facilitate transparency and comprehension of AI decisions and behaviors.
Absolutely, Samantha. Being able to explain how and why an AI algorithm arrived at a particular outcome provides valuable insights into its underlying reasoning. It allows users to identify potential biases, errors, or limitations. And in many domains, such as healthcare, finance, and legal sectors, explainable AI is not just a desire, but a regulatory requirement.
Spot on, Paul. By incorporating XAI techniques, machine learning models can be made more interpretable and justifiable. This allows users to make informed decisions, detect and rectify flaws, and minimize the risks associated with AI decision-making.
Exactly, Samantha. XAI techniques, such as rule-based models and feature importance analysis, enable a deeper understanding of the decision-making process. Rule-based models utilize if-then rules to make decisions, providing transparency and interpretability. And techniques like feature importance analysis provide insights into how the model is making decisions.
That's right, Paul. These techniques not only enhance transparency, but also facilitate legal and ethical compliance. With the increased adoption of AI technologies, there's a growing concern about accountability and transparency. XAI techniques help align AI technologies with legal and ethical standards by providing interpretability and explainability.
Absolutely, Samantha. XAI allows developers and users to identify potential biases and discriminatory behaviors in machine learning algorithms. This transparency not only helps build trust in AI systems, but also aids in complying with regulations like the General Data Protection Regulation, GDPR, or ethical guidelines set by organizations.
Compliance is crucial, Paul. XAI assists in mitigating the potential risks involved in the deployment of AI technologies and fosters a responsible AI ecosystem. It ensures that AI systems operate within legal and ethical boundaries, promoting fairness and accountability. Absolutely, and it's important to consider the ethical considerations and potential biases associated with XAI systems. As AI becomes more pervasive, there is a need to ensure that decision-making within these models is fair and transparent. Research should focus on identifying and mitigating biases in AI systems to ensure equitable outcomes.
Definitely. Ethical considerations such as explainability and transparency must be addressed within XAI to foster trust and accountability. Users should be able to understand the decision-making process of AI systems, making it easier to identify any errors or biases that may arise. This will ensure that AI systems are not only powerful and accurate, but also responsible and just.
And finally, the future of XAI looks bright. By enhancing trust, understanding, and accountability in AI systems, XAI has the potential to revolutionize critical domains such as healthcare, finance, and autonomous vehicles. It can facilitate widespread adoption of AI technologies and enable humans to collaborate effectively with these systems.
Absolutely. XAI techniques, such as feature importance analysis and local interpretability, play a key role in providing transparency and interpretability to machine learning models. These model-agnostic techniques uncover the reasoning behind the predictions made by AI models and enable users to understand the decision-making process.
That's right. Feature importance analysis helps identify the most influential factors driving the model's decisions, while local interpretability examines the model's behavior on individual instances and provides explanations specific to those instances.
By employing model-agnostic techniques, XAI enhances trust, accountability, and understanding of machine learning models. This promotes their adoption in high-stakes applications and ensures that AI systems are transparent and interpretable.
Absolutely. And it's worth mentioning that embedding ethics and fairness in XAI is crucial. As AI systems become more complex and pervasive, the need for XAI to be ethically responsible becomes even more pronounced. By incorporating fairness into XAI, we can mitigate biases and ensure that AI algorithms treat all individuals fairly and without discrimination.
Right. Ethical considerations such as explainability and transparency must be addressed within XAI to foster trust and accountability. XAI should allow humans to understand the decision-making process of AI systems, making it easier to identify any errors, biases, or unfairness that may arise.
And finally, explainability in deep learning models is a crucial aspect of XAI. As deep learning models become increasingly complex, their decisions and predictions are often seen as black boxes. XAI aims to address this limitation by developing methods and techniques that allow for transparency and interpretability of deep learning models.
That's right. By explaining the inner workings of these models, XAI enables users to trust and understand the decision-making process. This facilitates their acceptance and utilization across various domains.
And it's worth noting that explainability in deep learning models also enhances accountability, regulatory compliance, and ethical considerations. It helps prevent potential biases or unfair outcomes by providing insights into the underlying decision-making process.
Absolutely. Investing in the development of explainable AI techniques is vital to ensure the responsible and beneficial deployment of deep learning models in real-world applications.
In conclusion, XAI is a rapidly growing field within machine learning techniques that focuses on providing a clear understanding of how decisions are made by AI systems. It enhances trust, transparency, and ethical practices in the development and deployment of AI technologies.
That's right. Implementing XAI presents both potential benefits and challenges. On the one hand, it can enhance transparency and accountability in decision-making processes. On the other hand, there are challenges in striking a balance between interpretability and performance, especially in complex AI models like deep learning.
Absolutely. Despite these challenges, the future prospects for XAI are bright. It has the potential to revolutionize various domains, such as healthcare, finance, and autonomous vehicles, by enhancing decision-making processes and improving the accountability of AI systems.
And as XAI continues to advance, it can address concerns regarding bias and discrimination in AI, empower users by allowing them to comprehend AI models, and shape the development and deployment of AI systems towards a more responsible and transparent future. And it doesn't stop there, Samantha. XAI techniques also have the potential to improve decision-making processes and foster accountability. By providing transparency and interpretability, XAI algorithms enable humans to understand and scrutinize the reasoning behind the decisions made by machine learning models.
That's right, Paul. In high-stakes domains like healthcare and finance, where decisions have significant consequences for individuals and society, it's crucial to have a clear understanding of the decision-making process. XAI allows for better decision-making by empowering humans to make informed judgments.
And it doesn't end with better decision-making, Samantha. XAI also facilitates audits and regulatory compliance. Organizations can assess the fairness, bias, and legality of their algorithms using XAI techniques. This ensures that machine learning models align with ethical standards and societal values.
Absolutely, Paul. By integrating XAI techniques, we can mitigate potential algorithmic biases, identify errors or unintended consequences, and ensure the trust and acceptance of AI systems.
And the development and application of XAI techniques are crucial for harnessing the potential of AI while ensuring transparency and accountability in its use.
So, to summarize, explainable AI, XAI techniques enhance transparency and trustworthiness in machine learning algorithms. They assist in legal and ethical compliance, improve decision-making processes, and foster accountability. With the integration of XAI techniques, we can ensure that AI systems operate within legal and ethical boundaries while empowering humans to make informed judgments.
And there are various techniques to achieve explainable AI, such as rule-based machine learning, model-agnostic techniques like feature importance analysis, and symbolic AI techniques utilizing logical rules or ontologies.
That's right. Let's start with rule-based approaches. These approaches involve encoding expert knowledge or domain-specific rules into a system, which then uses these rules to make decisions or predictions. By explicitly defining the rules, this method allows for clear logical reasoning and interpretation of the decisions made by the system.
Absolutely. Rule-based models are particularly useful in domains where explainability and interpretability are crucial, such as legal or medical applications. However, they can be limited in their capacity to handle uncertainty or adapt to new data, as they rely on predefined rules that may not capture all possible scenarios.
That's a good point. Creating accurate and comprehensive rules can be a challenging and time-consuming task, requiring expert knowledge and constant updates to account for changing conditions or new information. Despite these limitations, rule-based approaches continue to be valuable.
Yes, and one specific type of AI technology that aims to replicate the knowledge and decision-making abilities of human experts is expert systems. These systems use a set of rules and knowledge bases to provide intelligent advice or make complex decisions. However, they have faced challenges related to their lack of explainability.
That's where explainable AI, XAI, comes in. XAI techniques focus on developing algorithms that not only provide accurate predictions, but also offer transparent explanations for their decisions. These techniques aim to enhance the trust and reliability of expert systems, making them more accessible and usable in real-world applications.
One popular technique for explaining the decision-making process of a model is through the use of decision trees. Decision trees are a flowchart-like structure where each internal node represents a feature or attribute, and each leaf node represents a class label or a decision. By recursively splitting the data based on different features, decision trees are able to capture complex relationships between variables and accurately predict outcomes.
Decision trees provide transparency and interpretability, allowing users to easily understand how a decision is made. They can even be converted into rule sets, making them even more explainable and applicable to domains where simple logical rules are preferred. However, it's important to note that decision trees can be prone to overfitting and may be biased towards features with more levels or categories, which can hinder their predictive accuracy and generalization capabilities.
Another approach to achieving explainability in machine learning is through the use of interpretable models. Interpretable models refer to algorithms that are designed specifically to provide clear and understandable explanations for their predictions or decisions. These models prioritize transparency and comprehensibility over higher accuracy, which may be sacrificed to some extent.
Interpretable models often adopt a rule-based or decision tree structure, where each decision or prediction is based on a set of logical rules. This allows users to easily trace the reasoning behind the model's output and understand why a certain prediction was made.
However, interpretable models may be limited by their simplicity and inability to capture complex relationships in the data. Therefore, the choice of interpretable models should be balanced with the specific requirements of the application.
One widely used interpretable model is linear regression. It's a statistical technique commonly utilized for predicting continuous numerical outcomes. It establishes a linear relationship between independent variables and a dependent variable, allowing for the estimation of the dependent variable based on the values of the independent variables.
Linear regression is advantageous in its simplicity and interpretability, enabling us to understand the impact of each independent variable on the dependent variable. However, it may not be suitable for datasets that exhibit complex nonlinear relationships, as linear regression assumes a linear association between the variables.
Nevertheless, linear regression remains a fundamental tool in machine learning and provides valuable insights for various practical applications.
Absolutely. So in conclusion, explainable AI techniques such as rule-based approaches, expert systems, decision trees, and interpretable models enhance transparency and trustworthiness in machine learning algorithms. These techniques enable us to understand and interpret the decisions made by AI systems, making them more reliable and accountable.
That's right. And one popular approach to achieving explainable AI is the use of post hoc explanations. Post hoc explanations refer to generating explanations for the decisions made by a machine learning model after it has made its predictions.
This approach is particularly useful when dealing with black box models, which are often difficult to interpret due to their complex structure. Post hoc explanations can take different forms, such as rule-based explanations or feature importance rankings.
Rule-based explanations involve formulating a set of rules that explain the decision-making process of the model. This helps shed light on how the machine learning model arrives at its predictions.
On the other hand, feature importance rankings aim to identify the most influential features in the decision-making process. By quantifying the impact of individual features on the model's output, we can gain insights into the underlying patterns and relationships between variables.
And feature importance analysis is not only useful for model interpretation, but also aids in feature selection. By identifying and ranking the importance of features, we can discard irrelevant or redundant features, improving model efficiency and reducing overfitting.
Absolutely. Feature importance analysis is an essential tool in the arsenal of explainable AI, contributing to improved transparency and trustworthiness of machine learning models.
Moving on, another approach to explainable AI is the use of local surrogate models. These models provide interpretability for specific instances rather than the entire machine learning model as a whole.
That's right. Local surrogate models help in understanding the workings of complex algorithms on an individual case basis. They approximate the behavior of the original black box model in the vicinity of a specific instance, providing explanations that can be easily understood.
These explanations are usually in the form of a simpler and more interpretable model, such as a decision tree or a linear model. By examining the local surrogate model, users can gain insights into the underlying decision-making process of the black box model at a granular level.
Local surrogate models are particularly useful in high-stake applications where interpretability and transparency are crucial for decision-making, such as healthcare and finance. They enable us to have a better understanding of how the black box model is making decisions, which is essential for critical areas.
Exactly. Explainable AI is an important area of research and development as machine learning algorithms become more sophisticated and complex. It's crucial for users and stakeholders to understand the rationale behind the decisions made by these systems.
Absolutely. By providing insights into the decision-making process, explainable AI not only ensures the accountability and trustworthiness of AI systems, but also enhances human understanding of the underlying mechanisms.
Various techniques have been proposed in the field of explainable AI, including rule-based models, local interpretation methods, and model-agnostic approaches.
These techniques aim to extract meaningful explanations and highlight the key factors influencing the output of machine learning models. By incorporating explainable AI techniques, we can improve the overall effectiveness and reliability of machine learning systems.
And not only that, but it also paves the way for ethical and responsible deployment of AI in various domains.
Absolutely. So it's crucial for researchers and practitioners to continue exploring and developing explainable AI techniques to ensure transparency, interpretability, and trustworthiness in machine learning models.
Well said.
One of the main challenges mentioned in the article is the interpretability and explainability of AI models when dealing with complex deep learning architectures. These models consist of numerous interconnected layers, making it difficult to understand the decision-making process behind their predictions.
That's right. The volume and complexity of data used to train these algorithms also pose challenges to interpretability. When the underlying models are trained on vast amounts of data, it becomes harder to explain how and why a particular decision was made.
Exactly. And another concern raised is that explainability in AI systems often relies on post hoc interpretability methods, which may lead to biased or incomplete explanations. This raises questions about the reliability and trustworthiness of these explanations, especially in critical applications like healthcare or finance.
Absolutely. We need to ensure that the explanations provided by AI systems are accurate, unbiased, and complete. Otherwise, there could be serious consequences if decisions are made based on flawed or incomplete explanations.
Another challenge highlighted in the article is the trade-off between accuracy and explainability. Complex models often outperform simpler, more interpretable ones in terms of accuracy. So striking the right balance between accuracy and explainability becomes crucial.
Yes, finding that balance is essential, especially in critical applications where both accuracy and interpretability are important. For instance, in healthcare or finance, it's crucial to have accurate predictions, but also be able to understand how those predictions were made.
Absolutely. And this leads us to the next point discussed in the article, balancing between transparency and model complexity. Transparency refers to the ability to understand and interpret a model's decision-making process, while model complexity relates to its accuracy and performance.
right? A highly transparent model can provide insights into how it reached a particular decision, which is especially important for critical applications like healthcare or finance. However, a more complex model might yield higher accuracy, but at the cost of reduced interpretability.
That's the challenge, finding the optimal trade-off between model complexity and transparency. Researchers are continuously working towards developing machine learning techniques that strike this balance, enabling both high accuracy and interpretability.
And it's not just about accuracy and interpretability. The article also discusses the trade-off between explanation quality and model performance. As ML models become more complex, their performance improves, but their interpretability decreases.
Yes, that's a crucial aspect to consider. While achieving high accuracy is desirable, it's also important to understand the underlying rationale behind the model's decisions. Explainable AI techniques aim to bridge this gap by providing insights into the decision-making process, but the quality of those explanations may not always accurately reflect the model's internal workings.
That's right. So finding the right balance between model performance and explanation quality is necessary. We need to carefully consider the specific requirements and objectives of a given application when deciding how much emphasis should be given to explanation quality.
Absolutely. And finally, let's talk about overcoming black box models. The use of black box models in machine learning limits the interpretability and transparency of the decision-making processes.
Yes, it's a major challenge, but there are approaches being developed to address this issue. One approach is to develop techniques that provide explanations for the decisions made by the model. By understanding the underlying reasoning, humans can better trust and validate the outcomes generated by machine learning algorithms.
Exactly. Another approach is to use interpretable models that are inherently transparent and can be easily understood by humans. Models like decision trees or linear regression not only offer explanations, but also allow users to understand the relationships between input features and output predictions.
And finding the right balance between accuracy and interpretability is key to successfully implementing explainable AI systems in real-world applications.
Definitely. It's about finding that sweet spot where we have accurate predictions that can be understood and trusted by humans. And as the article mentioned, the development of explainable AI techniques is crucial to enhance trust, accountability, and wider acceptance of machine learning systems in critical decision-making situations.
Absolutely. The more transparent and interpretable AI models are, the more likely they are to be trusted and adopted across various domains. One domain where explainable AI has shown great promise is healthcare. Machine learning models can assist doctors in diagnosing patients accurately and providing personalized treatment recommendations. These models analyze large datasets to identify patterns and correlations that may not be evident to human clinicians, leading to more accurate diagnoses. And by understanding the reasoning behind the AI model's recommendations, healthcare professionals can make well-informed decisions regarding medication dosage, surgical interventions, and other treatment modalities.
That's right. The interpretability of machine learning models is crucial in healthcare because it enables clinicians to trust and understand the recommendations. Explainable AI plays a vital role in ensuring patient safety and well-being. And with the integration of machine learning in patient monitoring and care planning, healthcare providers can now access reliable and interpretable models. These models analyze patient data, such as physiological parameters, medical history, and treatment results to provide accurate predictions for potential health risks and suggest personalized care plans. This integration not only improves the efficiency of patient monitoring, but also facilitates evidence-based decision-making, ultimately leading to better healthcare provision.
Absolutely. And while the application of machine learning techniques in healthcare is highly promising, there are challenges that need to be addressed. One challenge is data quality. Machine learning models heavily rely on large data sets, and if the data is inaccurate or incomplete, it can lead to unreliable predictions. Another challenge is algorithm bias. If the training data used to develop the AI model is biased, it can result in discriminatory or unfair outcomes. And finally, patient privacy concerns need to be addressed to ensure that sensitive medical information is protected.
You're right. Addressing these challenges is crucial for fully harnessing the power of explainable AI in healthcare. Investments in research, development, and robust regulatory frameworks are imperative to ensure the ethical and responsible use of machine learning techniques. This will enable a future where healthcare professionals and AI systems work synergistically to provide optimal care for patients.
Now, let's shift our focus to the finance industry. The integration of machine learning techniques, particularly explainable AI, has brought significant advancements. Explainable AI in finance offers several benefits. First, it allows financial analysts and investors to better understand the reasoning behind a machine learning model's predictions. This increases transparency and trust, which are crucial in the finance industry where accurate predictions are highly sought after.
Absolutely. XAI techniques in finance also help identify relevant features and factors that influence financial decisions. This aids in risk management and portfolio optimization. By providing insights into the inner workings of machine learning models, XAI helps reduce biases and improves decision-making processes.
That's right. The interpretability of machine learning models in finance is essential for financial professionals to trust and rely on the predictions made by AI systems. With the integration of explainable AI, financial institutions can generate interpretable credit scores and risk assessments, which can be used to determine loan eligibility and make informed financial decisions.
And not only that, but XAI techniques also play a pivotal role in ensuring the fairness and non-discriminatory nature of AI systems in areas like hiring and criminal justice. These are domains where decisions have critical implications for individuals, and it's essential to have transparency and interpretability to avoid biases and discrimination.
Absolutely. Explainable AI has emerged as a crucial tool in bridging the gap between machine intelligence and human understanding across various domains. It offers the potential to enhance transparency, interpretability, and accountability in complex machine learning models.
And as we've discussed, in healthcare, XAI can revolutionize the industry by enhancing diagnostic accuracy, improving treatment outcomes, and facilitating personalized healthcare. In finance, XAI helps financial professionals make informed decisions, understand the reasoning behind predictions, and reduce biases. These are just a few of the many domains where explainable AI is making a significant impact.
That's right. In the field of fraud detection, machine learning algorithms have become critical in identifying and preventing fraudulent activities. However, the lack of interpretability in these models has raised concerns. Explainable AI techniques can provide human understandable explanations for the decisions made by machine learning models, allowing investigators to gain insights into suspicious activities and enhance the overall effectiveness and transparency of fraud detection efforts.
Another area where XAI is crucial is credit scoring and loan approvals in the financial industry. Machine learning models used for credit scoring must be explainable to ensure fairness and accountability. By understanding the factors that contribute to loan approvals, lenders can better assess the creditworthiness of borrowers and make informed decisions. Techniques such as rule-based models or decision trees provide interpretability and explanations for individual decisions, allowing lenders to enhance trust in the loan approval process.
Absolutely. Transparency and comprehensibility are vital in credit scoring and loan approvals to ensure a more efficient financial ecosystem. XAI techniques can address this by explicitly mapping input features to model predictions, enabling users to trust and comprehend the outputs.
Moving on to autonomous vehicles, which are garnering significant attention in the field of machine learning. These self-driving vehicles have the potential to revolutionize transportation systems, but their safe and reliable operation is a critical concern. XAI techniques can make the decision-making process of autonomous vehicles more transparent by providing insight into the contributing factors for a particular action taken by the vehicle. This level of explainability enables users and regulators to trust autonomous vehicles and understand their actions.
Additionally, XAI techniques can detect biases in autonomous vehicle decision-making that might arise from bias training data, making it possible to correct them and enhance the fairness and justice of autonomous systems. This is crucial in ensuring that autonomous vehicles operate ethically and in a manner that is fair for all users.
Moving on to decision-making in critical situations, XAI can facilitate better decision-making by providing transparency and interpretability. In high-stakes circumstances, individuals may experience intense pressure, limited time, and a high degree of uncertainty. By understanding the underlying reasoning processes of AI systems, humans can gain trust and confidence in the decision-making process, enabling them to make more informed choices.
And XAI allows decision makers to comprehend the potential risks and limitations associated with AI-driven decision-making. This empowers them to take appropriate actions, such as seeking additional information or overriding system recommendations when necessary in critical situations. XAI can greatly enhance decision-making in fields such as healthcare, emergency response, and crisis management.
Absolutely. And finally, XAI has the potential to revolutionize accident reconstruction and liability determination in motor vehicle accidents. XAI enables experts to create models that not only predict the likelihood of an accident, but also provide detailed explanations for the decisions made. This transparency allows stakeholders to better understand the factors that contribute to accidents and determine liability more accurately.
Moreover, XAI can analyze vast amounts of data, making it possible to identify patterns, contributing factors, and potential risks that human investigators may overlook. This technology has the potential to revolutionize accident reconstruction, leading to more reliable outcomes in terms of liability determination and providing the necessary insights to prevent future accidents.
In conclusion, Explainable AI, XAI, is crucial in addressing the lack of transparency and interpretability in complex machine learning models. By incorporating XAI techniques, we can enhance trust, understanding, and accountability in various domains such as fraud detection, credit scoring, autonomous vehicles, decision-making in critical situations, and accident reconstruction.
XAI provides human understandable explanations for the decisions made by machine learning models, allowing users to comprehend the model's outputs and make more informed choices. It also enables error detection, debugging, and bias identification, ensuring the robustness and reliability of AI systems.
Absolutely, and the article highlights some future directions and ongoing research in the field of XAI. One important direction is the development of more interpretable ML models. Currently, many ML models provide accurate predictions but lack explanations for their decisions. So, researchers are exploring novel architectures and algorithms that strike a balance between complexity and interpretability.
That's right. Another important aspect is the standardization and benchmarking of XAI methods. This is necessary to ensure comparability and reliability across different domains and datasets. By establishing standardized evaluation metrics and datasets, researchers can assess the performance of different XAI techniques and compare their effectiveness.
Additionally, integrating domain knowledge into ML models is another promising direction for future research. By incorporating knowledge from experts in specific fields, we can gain a more holistic understanding of the decision-making process. This can help improve the accuracy and reliability of AI systems in critical domains such as healthcare, finance, and autonomous vehicles.